So far we've been plotting in one dimension on the real number line. We've plotted things like x equals 2. I said, alright, here's a real number line. Let me put a line here. We'll call this location 0. And we can just count in the positive direction to 2 and say, alright, well there's x equals 2. We'll just fill in that. We could do something like x equals minus 1. We'd come back from 0 to the left to our negative numbers. We'd say, alright, well here's negative 1, negative 2. If x equals negative 1, it's right here. Right, and we can plot all of these. We don't necessarily have to plot an integer. We could say x is equal to 3/4, and then we'd make an estimation. We'd say, well, it's approximate, it's between 0 and 1, so maybe here's a half, 3/4 might be right here. Okay, we've done that. So now let's look at taking these real number lines and putting two of them together, one rotated 90 degrees from the other. So I'll put one number line down. And again, we're going to start at 0, count from 0, 1, 2, 3, it could be 5, 10, 15, but we'll just go with this. So this is our sort of plus direction, just like our number line that we're used to. This would be the negative direction, so from 0 we'd have negative 1, negative 2, etc. But I'm going to put another number line 90 degrees from the first, going right through 0. It's supposed to be going right through 0. Right there. And we've rotated at 90 degrees, or it's at right angles, and the positive direction on this axis we're going to have being in up, or that would be our positive axis. And then again, it's a real number line just tilted on its side. You can turn your head 90 degrees and see that, oh, this is, turn your head 90 degrees to the left, and you'll see this is the same idea. We have 1, 2, 3 going in the positive direction, and the negative direction, of course, would be down below. Negative 1, negative 2, etc. So this is what's called a Cartesian coordinate system, or a rectangular coordinate system. And it's comprised of quadrants. We actually give each of these squares, if you will, a name. We call this the first quadrant. The second quadrant, it goes in counterclockwise direction. The third quadrant is here. And the fourth quadrant in this location. So there are 4 quadrants. They go counterclockwise around these the system. Now we can locate points on this plane. Alright, so if I wanted to tell you where your desk was, say in a classroom, I might say something like, because I'm a math teacher, I might say start in the middle of the room. Alright, start right in the middle of the room. So maybe this is the floor of our room. And I might say, alright, we'll start in the middle. So you start in the middle and go 3 desks to the left. So you start walking to the left. 1 desk, 2 desks, and 3 desks. There would be a 3 here. And then I say, okay, now go 2 desks up. So you'd go 1, 2, and your desk would be located right here. Right? At this location, 3 to the left, 2 up. Right? In mathematics, what we do is we give that point, this point right here, we call it a position or a point in space, in two-dimensional space, and we say we give it the designation of an ordered, what we call an ordered pair. So I would, in shorthand in mathematics, I would say this is the location -3, 2. Notice I've come -3 on this horizontal axis and up 2 on the vertical axis. The most common designation for these axes is the x-axis and the y-axis. We usually put an x and a y next to them. X is common. It could be t, it could be any variable name I wanted to call it, but it's often x and y. And I call this point an ordered pair. It's a pair of numbers, that's the first thing, there are two of them, and they're ordered, and it's very important that they're ordered. I am always going to tell you the horizontal or x dimension first, and then the vertical or y dimension. They are always x and then y. So as a math teacher, I would tell you the x dimension first. I'd say go 3 to the left and 2 up, rather than saying go 2 up and 3 to the left, even though it would get me to the same position. But I'm always going to tell you the horizontal motion first in an ordered pair. Okay, so let's try some of these. So let's plot, we're just going to sketch. You can get some graph paper and make this look really nice. Let's plot the point 1, comma, minus 2.5. All right, now remember, and it's sometimes handy to write down that this is x and then y. So let's just get ourselves a coordinate system here and here. This is x, this is y. I don't really need to put the arrows on. Okay, I'm back. I don't know if you heard that phone ring, but now I'm back. I'm trying to remember where I left off. Anyway, we have two axes. We have the x and the y. I know that to the right on the x-axis is positive, and I know that up on the y-axis is positive because I know I'm in a Cartesian coordinate system. And I've been given a point, 1, minus 2.5. So I'm just going to label these and put a grid on here because I don't have one. So I'll just call this 1, 2, 3, just like we would in a real number line, right? These would be the negative numbers along the what we call the x-axis. Minus 1, minus 2. Where's 0? Yeah, 0 is right here where the two axes cross. And the only reason I'm not putting it in is because it gets a little messy. All right, but I know that 0 on the x-axis is right where the y-axis cuts through it. We can also label the y-axis 1, 2, 3. So this would be 1, 2, 3. And in the negative direction as well. Minus 1, minus 2, minus 3. So remember that 0 is located where the two axes cross. 0 on the y-axis and 0 on the x-axis. So let's look at this point 1, minus 2.5. I know it's an ordered pair because it's in parentheses. And I told you it is, and I'm plotting it, so it must be. And remember that the x value comes first, and then the y value. And sometimes, like I said, it's handy to put a little x and a little y just as a reminder. So I'm going to plot the x point, this x equals 1, on the x-axis just like I would when I was plotting on the real number line. So I know I'm right here. Right, so I've gone over 1. And then on the y-axis I'm at negative 2.5. 1, 2. Negative 2.5 is about here. It's about halfway in between. So I'm just going to sort of make a dotted line so you can see where we're going with this. 1 on the x, 2.5 on the y, where they sort of intersect. That's my point. That's where it's located. Get rid of these. All right. So that's what it would look like. And often what we'll do is we'll actually put a little note to ourselves that this is the point 1 comma minus 2.5, x and then y. What about, let's plot another point. Let's plot the point minus 2 comma 0. Where's that? Well, again, the minus 2 is the x and the 0 is the y. And where was y 0? Well, it was where the x-axis crossed it. So what this is telling me is because the y value is 0, I'm only on the x-axis. So I come over here to x is minus 1, minus 2. My point is right there. It's on the x-axis. So there are two axes. There's an x and a y. And again, we can just label this point minus 2 comma 0. It will be very similar with the y-axis. Let's do one more. Let's do 0, 3. I'm just using integers because it's easier, but like the first point, we don't have to. We can plot any real number along here, but x is 0, and now y is 3. Right? Because they're always in ordered pair, x first, y second. So if x is 0, I'm on the y-axis, right here. So this is the point 0, comma 3. Very good. In the next video, we'll look at solving some linear equations in two variables, and we can use this coordinate system and Cartesian coordinate system to plot our results.